All right, let's go. Gonna take all of the bits and pieces off of the donor controller here. So obviously start by opening it up with a tri-wing. This controller only had 3 screws in it, which somebody's been messing with it before, but that's fine. Good to have a container to put everything in. A few tiny screws that can be pretty easy to lose. Okay, first thing is take the board out of the shell and take the rumble bracket off of the board. You can keep all the buttons and stuff in the shell, and then you don't have to screw with them. There we go, rumble motor out, trigger boards out of the bracket, and put the bracket with the other stuff. Take off the analog stick. You can leave the C-stick in place. And first thing to do is take out the analog stick box. So you'll need a tiny Phillips screwdriver for this. Those are the screws that are easy to lose. Alright, next gotta pop the potentiometers off of the stick so you can get it out. I just use a flat-bladed screwdriver head for this. You might actually want to do this before unscrewing the stick box from the back. Probably would be a little bit easier. You can see I have to hold it there. Okay, so we're going to take a little detour here to show gluing the magnets, because this is the first thing you want to do. You can wait for the magnet or the glue to dry while you do the rest of the construction. So first, start out with some alcohol and a Q-tip and thoroughly clean the tab that sticks out of the stick box that interfaces with the potentiometer. You want to make sure that there's no grease or stuff there that can make it so that the glue doesn't adhere properly. There we go. So I'm just going to quickly show how you can set up a very simple setup for holding the magnets in place. Basically, you just need to support the magnet while the glue dries to make sure that it doesn't fall off. So here's an example. You can grab some small tweezers, put an elastic band around it to make it so that they have just a little bit of clamping force. And then grab your magnet and hold it with the very tip of the tweezers. Just grabbing the magnets there. Magnets are also very small and very easy to lose, so be careful when you're handling them. Unfortunately, the camera doesn't focus, but I think once I put it down, yeah, now you can see it okay. So basically, you just got to line it up so that the direction the magnet is pointing is horizontal for the stick box, so at a right angle to the actual stick of the stick box, and get it right centered on that tab. You want to play around with the positioning a little bit before you actually put the glue on, but that's basically it. So if you were doing it that way, you would then you want to do that somewhere where you're not going to be working on the other stuff, because you just need to leave it for, say, maybe even 2 hours to make sure that the glue is starting to dry. But as you see here, I made a little jig for holding them. It doesn't really speed the process up, but it makes it a little easier and a little more consistent. I think some people are looking at making 3D printable jigs for holding the magnet, but to my knowledge, nobody shared anything yet. So this is what I made. I know that probably most people would not be able to. This is not an option for most people, but it works reasonably well. I still have to adjust the magnet position back and forth to make sure that it's lined up with the tabs, but once it's lined up, it's just holds it in place, and I don't have to worry about it. Almost right. All right, I'm happy with the positioning now, so it's time to add a bit of glue. This is the glue I use. It's the Gorilla Glue gel super glue. This seems to work pretty well for me, but it's certainly other things could work. I think the most important thing is that it needs to be a very viscous glue so that it will actually stay in place and kind of bridge the gap between the tab and the magnet. But, you know, a thick 2-part epoxy or something could probably work quite well, and probably other options too. Okay, stick box is in place with the glue. So now I'm going to add on this little clamp to hold the stick box down. If you're just positioning them manually, all you need to do is make sure that you line up the magnet with the tabs. But if you are making a jig of some sort, you need to be aware that if the stick box is not clamped down or screwed down with the screws that normally hold it to the board, it actually comes apart slightly, and so the positioning of things can be a little bit different. So yeah, if you're making a jig, be aware that you need to you need to hold the stick box in place in some way. This is how I've done it. There we go. Just squeezing the magnets in, making sure that they're making good contact. And that's it. I'll set that aside and revisit it later. Okay, on to removing the components from the board. This is my vise. I know that probably most people that are doing this don't have a vise like this. It's not absolutely necessary, but it makes everything so much easier. Being able to hold the board securely and use both hands for doing the other operations. Yeah, if you can get something like this or find something like this, I definitely recommend it. Alright, so I think we're going to start here with the trigger boards, because they're the easiest. Gotta let my soldering iron heat up a little bit first. I don't think I use flux here for any of these components, but it can be helpful for desoldering if you're having trouble making good thermal contact to get the solder joints to actually melt. A little bit of fresh solder, or there we go. There's a little bit of fresh solder, or flux on the board can make a huge difference. So for these, you just got to heat up both of the connections at the same time so that they melt, and just pull the wires out. Pretty easy. Same thing for the other side. And basically same process for the C-stick board. Some of these have an actual connector rather than just a ribbon cable running to them. For the connector, you might have to, it's harder to desolder the pins kind of a bit at a time. So you may have to do this wire across them trick that we'll look at later for the connector to melt all of them at the same time. But it's only 4 pins, it's not that difficult. Next is the Z button. So unfortunately the camera doesn't want to focus here at first, but I think later on it's okay. Okay, so this is the method that I use to desolder all of the kind of tricky components. Rather than trying to grab onto them with pliers or something to pull them out, I use some sharp tweezers and insert them underneath the component, and then I can kind of push the tweezers in to wedge and lever the component out while I melt the solder joints. Just got to get this position there. There we go. So here you have to, the switch has 2 sides, and it has 2 solder joints on each side, and you have to heat up both the actual electrical connection pin and this mechanical connection pin that's at the edge of the board at the same time to get it to come out. So you can see I'm swapping back and forth between the sides, alternating heating one, then the other, and slowly working the component as I go. and yeah, it pops out. I think next up is the sliders. Let's see. Yeah, as you can see, being able to position the board in different ways is just super helpful. Okay, so same thing here. I have the tweezers underneath and tucked underneath the slider so that I can kind of push it out as I heat up the solder joints. This solder joint was a little bit dirty, had to stop and clean it off to be able to get the soldering iron in there. But for the sliders, there's it has 5 pins that you need to heat up. 2 at the bottom, which are spaced kind of far apart. You can see me alternating between them there. And the 3 at the top, which are all together. So you need to, for the 3 at the top, you pretty much need to heat them all up at the same time. You can see me kind of dragging the soldering iron across them there to get them heated up at the same time. The 2 at the bottom, you need to alternate. So it's the same thing. You kind of work the component out as you go around and heat up each set of joints a little bit at a time, moving the component out a little bit of the time, a little bit at a time, until eventually it pops out. These you just got to be patient with, is what it comes down to. There we go. Same thing for the other one. Again, wedged this is a little trickier to see this time, but wedged the tweezers underneath and just going around and heating all of these joints up one at a time, slowly working the component out. I think I had a little bit more trouble with this one. I had to stop and reposition the tweezers to be able to get enough leverage. Sometimes it can also be hard to tell which solder joint is actually still holding it on. But again, patience. You'll be able to get them out eventually. Yeah, there I'm checking, trying to figure out what's going on. Why isn't it coming out? Almost there. There we go. Almost. There we go. Okay, and then I think lastly is the connector, the cable connector. So this can be a pain because you essentially have to heat up all 6 solder joints at the same time to get the connector to come out nicely. And the pins that they use, at least the ones that I've looked at, they're not just regular straight pins. They're actually kind of like a spring pin, so they hold themselves in mechanically in addition to the solder. So it's a pain. So this is a trick that I do for if I have to desolder a bunch of pins at once. You can solder a fairly thick piece of copper wire across all the pins and basically use it to share the heat between all of these pins and melt the solder on all the joints at the same time. So you can see me dragging the soldering iron back and forth across it, heating them all up while I'm pulling and wiggling the connector. And yeah, it pops out, as you see. At this point, if you wanted to reuse the board, you could go in with a solder sucker and solder wick and clean up all of those joints, but I'm not using it again, so that's basically it. I did try to record the whole thing in one go, but my camera failed halfway through, so this is the first part. I'll have to set it up and try again for actually putting the components back on the board. All right, that's it.